Hello and welcome to the YouTube channel D Creations Resources. We are solving different problems in mathematics, especially complex analysis, and since last few episodes we've been talking about Taylor series. So the question is, find the Taylor series for cos z about z0 is equal to minus 2 pi I in the region mod z less than infinity. Now, certain things that you need to take into account here is, first of all, the expression for cos z, the series expansion, n going from 0 to infinity, z raised to 2n divided by 2n whole factorial. And of course, this is true if z0 is 0. Now, in our case, z0 is given to be minus 2 pi I. So, z minus z0 is going to be z plus 2 pi I. So let us look at the expression of cos of z plus 2 pi I. Now if you expand it, it is cos z cos 2 pi I sin h z sin h 2 pi I. Now cos 2 pi I is equal to cos 2 pi, which is 1. So if you substitute it here in the first term, you get only cos z, and sin h 2 pi I is I into sin 2 pi, which is 0. So the second term vanishes. So the answer is just cos of z. So now you have to substitute z plus 2 pi I in the expression, and the answer that you get is n is equal to 0 to infinity z plus 2 pi I raised to 2n divided by 2n whole factorial. Now similarly, there's one more question where you have to find the Taylor series for e raised to z about z0 is equal to 1 and the region mod of z minus 1 is less than 1. Now e raised to z, it's one of the uh, most important functions, and the series expansion is what we usually begin with. So it is summation n going from 0 to infinity of z raised to n upon n factorial. Now this is the Taylor series about z equal to 0. Now if you are thinking of writing e raised to z in terms of e raised to z minus 1, obviously e raised to z is e into e raised to z minus 1. So e raised to z minus 1 will be n going from 0 to infinity z minus 1 raised to n upon n factorial. So now substituting it in the given expression, e raised to z is e into this expression, that is n is equal to 0 to infinity z minus 1 raised to n divided by n factorial. So that is going to be the answer here.